Okay, so we're going to look at the properties of logarithms, starting with the product property. Now, the big part about this property that you need to know is this right here. If I have the log base b of x times y, so I'm multiplying in the argument, then that's the same thing as splitting that into the log base b of x plus the log base b of y. Okay, now notice that when you do that, let me zoom in a little bit here. Okay, when you do this, when you make the split, both of my new, the two pieces from the argument that were multiplied together, okay, they both are going to have the same log base b that goes with them. So I'm going to get a log base b of x plus log base b of y. Okay, now you may be wondering, why do I go from multiplication to addition? And I'm going to show you why. This is what I call a proof. Okay, it's a very, very simple, basic little proof. Okay, just to show the reasoning behind the fact that we end up with that x plus the log base b of x plus the log base b of y when we started with multiplication. Okay, so to prove this, we're going to start with the basic property. Log base b of x times y is equal to the log base b of x plus the log base b of y. Okay, so in this proof, essentially what's going to happen, and this is very common practice when you're trying to prove things, is I'm going to give this thing a value. Log base b of x, it has to be equal to something. I don't know what it is, okay, but I'm going to give it a name. So log base b of x, and we're going to say that's equal to m. M is very generic, okay, m could be anything, but we just wanted to give that a value, and I'll show you why here in a second. So I'm going to do the same thing for log base b of y. We don't know what log base b of y is equal to, but it's got to be equal to something, and we're going to call that something n. Okay, and the reason why I'm doing that is because that's going to allow me to change this thing to the exponential form, which is what we learned in 12.4. And the exponential form, that might have been 12, might have been a different section. It might have been 12.3. I'm not sure. But either way it goes. Okay, allowing us to switching these things to exponential form. So remember we did the little circular thing. If you're in class, I called it the snail. You start with the base. Okay, the logs are always equal to the exponent, so base raised to the m power is equal to x. Well, now I'm going to be able to work with exponentials instead of logs, because we have all of these properties about exponentials that we've already covered in this class that I can use. So same thing here, b raised to the n power is equal to y. And again, that's using that snail method where you just loop around. Start with your base, exponent, argument goes at the end. So b to the m is equal to x, b to the n is equal to y. Well, now if I go back here, somehow I have to go from multiplication to two different additions. So I'm going to start with just that multiplying. So x times y. Okay, well I just got done saying that x is equal to b times n. That's what I just found. Okay, so instead of x, I'm going to say b to the m power times, instead of y, I'm going to put in my value for y. Y over here is b to the n power. Okay, well what happens when I multiply bases? Okay, when I multiply bases, I add exponents. This is one of those exponential properties that we covered last, I believe that was last semester or last 9 weeks. Okay, so b to the m plus n. Okay, b to the m plus n. So when I multiply bases, I add their exponents. That right there is how I get a plus with logarithms. Because remember, when you talk about logarithms, you're talking about the exponents. That's what a logarithm is. Logarithms are equal to exponents. So when you're talking about multiplying in there, what's really going to end up happening is we're adding those two things. Because when you multiply bases, you add exponents. Okay, so now we're here. So we're going to go ahead and finish off this proof. We've got the plus sign in there, so that's good progress. I can't speak. Okay, so that's still equal to xy, because if xy is equal to this, which is equal to this, then this has to be equal to the xy. Okay, so now if you look at just this piece, I can convert this back to logs. Okay, because I want to go back to logarithm. So I'm going to go log. Okay, we use base b. You always start with the base. Log base b of, we circle around, okay, xy is equal to the exponent, because logs are equal to their exponent, can't say that enough, so m plus n. So this is good. We're back to our xy, so we got the left-hand side. Now we have to make this match up with the right-hand side, and we'll be done. Well, that's simple. What is m equal to? Well, I wrote it up here. m is equal to log base b of x. So log base b of xy is equal to, the m is log base b of x, plus the n is equal to log base b of y, log base b of y. Okay, so we're able to go full circle. So that is proof that the log base b of xy is equal to log base b of x plus the log base b of y. Okay, so that would be the end of the proof. Some professors use like a little square. Sometimes they fill it in to show the end of a proof. You may see that as you move on to college, so I just wanted to give that a little exposure to you. Okay, so now, if I want to write these things as a sum of a single logarithm. So this was all just a proof to show that this property really is true. But now what we really want you to be able to do is utilize this property. Okay, so if I have the log base b of x times y equals log base b of x plus the log base b of y, that means I can also go the other direction. So if I have two logarithms being added together, I can multiply the arguments to simplify this. Okay, so they want me to write this as write each sum as a single logarithm. Single literally means I want one logarithm left in this. I've got two right now, log and log. Okay, so log base 11 of 10 plus log base 11 of 3. My bases match, which means I just multiply those arguments. So log base 11 of 10 times 3, which is just log base 11 of 30. And it's as simple as that. Okay, when I add two logarithms to simplify, I multiply their arguments. And I write it. Now I have one log, a single logarithm. Okay, so if you have more than one, then you're not done. You have to keep going. Here on B, okay, log base 5 of 3 plus log base 4 of 3. Okay, well there's a problem there. I've got a 5 here and a 4 here. And it specifically states in our property that the bases must be the same. They're both B's. Okay, our bases must match up. We can't do this when the bases don't match. So different bases means you can't add. Okay, different bases, and that's the little numbers. Remember, the bases are the little numbers. It's very important you know your vocabulary, because I'm going to talk a lot about bases, arguments, and exponents, and you need to know which ones are which, okay? Tiny little numbers, those are your bases. The number in front of the, or at the end of the log here, that's your argument. And if I had a number, a small little number up top, a superscript is what that's called, then that would be your exponent. Okay, so can't add that, so here, log base 2 of x plus 2 plus the log base 2 of x, I can add those together. Okay, I do that by multiplying the argument. So here we go, log base 2 of, it's going to be x plus 2 times x. Okay, when I add logarithms, I multiply their arguments. Okay, well, how do I do x plus 2 times x? That's basic algebra. Okay, don't overthink it. You just distribute, so I end up with x squared plus 2x. Notice that I have parentheses. Those parentheses must be there. If you do not put parentheses around this, it is very incorrect. Okay, because we want the x squared, the entire thing, x squared plus 2x, to all be part of the log. If we don't put the parentheses, then the only thing part of the log would be the first term, which is just the x squared. And 2x would just be added on to it afterwards. And we don't want that. We want all of that to be part of the logarithm. Okay, so that would be your answer there. Log base 2 of x squared plus 2x. Now that's the product property. Okay, so that's what happens when we're multiplying. Okay, and adding two logarithms becomes multiplication. Well, quotient property is almost the same, so I'm not going to show you the same proof, because you would just replace all of your multiplication with division and change all of the addition to subtraction. Because if you think about your properties of exponents again, when I am dividing, okay, I would subtract the exponents. If I divide bases, so if I had like x to the third over x squared, right? If I'm dividing the same bases, I subtract exponents. 3 minus 2, which would just be x to the first power, or x. Okay, so that's where this is coming from. So when I am dividing here, I am subtracting logarithms, or vice versa. If I'm subtracting logarithms, then I could divide the arguments. Okay, so, and one more thing I want to point out, and this was true in product property, and I forgot to mention it. We don't look at the base of 1. Okay, the reason why we don't look at a base of 1 is because you have to imagine that this is a Whenever you're doing this, you're talking about the exponent. So what this would say is that we would have 1 raised to some power. Well, 1 raised to every single power is just 1. So there's no point of looking at logarithms, because the only answer there could be is 1, because I can raise 1 to all kinds of different exponents, and I'm still going to get 1. So we don't look at bases of 1 at all. So I just wanted to make a little note, and that's true of all of the properties: product, quotient, product, all of the above. You have to have a base that is positive and greater than 1. So, or as long as it's not 1, really. Okay, so now looking at that quotient properties for A, log base 10 of 27 minus log base 10 of 3. Okay, so I'm subtracting 2 logarithms. So in order to subtract them, log base 10, we divide arguments. 27 divided by 3, make sure you reduce. Log base 10 of 9. Now I do want to note that whichever one is listed first must go on top. Okay, whichever one has the minus has to go on bottom. You can't just switch the order to make it nicer for you. If you end up with a fraction, you just leave the fraction. Okay, you simplify it as much as you can. So it's got to be the first one on top and the second one listed on bottom if it's if you're subtracting there. Okay, so here log base 5 of 8 minus log base 5 of x. Our bases are the same. They do have to be the same. Our property says so. Okay, so my bases are the same, so we just divide log base 5 of a over 8 over x. I said a. But that's how you would subtract those 2 logarithms and write it as a single logarithm. I have 1 log left, log base 5 of 8 divided by x. Okay, so last one here, same sort of idea. Okay, log base 5 of x squared plus 5 minus log base 5 of x squared plus 1. So I get log base 5, and you go ahead and divide x squared plus 5 over x squared plus 1. Okay, so you go ahead and divide those out. Now that's your answer. You need your parentheses here, and that's going to be your answer. You can't cross out x squareds, because if you remember from when we were doing rational expressions, that you can't, if it has a plus in between them, those things are bound. Okay, remember they're married or holding hands or however you want to think of them, but those two things are bound together with that plus sign, so I can only cross out an x squared plus 5 with another x squared plus 5. The only other option is to factor if it does factor, but this does not factor. Okay, so that is just my answer, log base 5 of x squared plus 5 over x squared plus 1. Okay, now last property, there's only 3 properties. Okay, there's 3 what I like to call the action properties, if you will. We've got product, quotient, and power properties. Now that's not counting the 3 special properties that I showed you on the very first day of this unit. Okay, you have to know those also. So 6 properties in total that you need to know. Okay, and we're going to see these again when we look at natural logs, but they'll be the exact same properties, only with natural logs in them, and we'll talk about what those are later. So now use the power property. Again, b is not allowed to be 1, has to be positive, has to be real. Okay, and r is also going to be real. And all this says is that log base b of x raised to the r power is equal to r times log base b of x. Okay, so what that says is if I have an exponent over here on my argument, that exponent can come down front, okay, and become multiplication. I can also go the other way. If I had a number in front of a logarithm, I can move it back to the exponential spot on the argument. Okay, again, that vocabulary is super important. Make sure you understand which piece is which. So right here, I've got a base, an argument, and an exponent. So by the power property, I am allowed to take that exponent and put it in front of the logarithm. So this would become 3 times the log base 5 of x. I still have an argument. Okay, the only thing that moved was that exponent moved to the front, and it becomes a normal size number, if you will. This literally means 3 times the log of base 5 of x. Okay, so the same thing here. They want us to use the power property. Well, I have no exponent, at least not one written. But really there is an exponent, because you have to remember that the square root of 2 is the same thing as 2 raised to the 1/2 power. Okay, that's what a square root means. If it was a cubed root, it would be 2 to the 1/3 power. If it was a fourth root, it would be 2 to the 1/4 power. Okay, that's what those radicals mean in exponents, is 1/2. So whenever I do that, I get log base 4 of 2 to the 1/2 power. Well, now I can take that exponent and move it to the front. So I get 1/2 log base 4 of 2. Okay, be very careful with these. Make sure your base looks like a base. Make sure your argument looks like an argument. If you start getting to where you're writing stuff like log base 4, and you got like this tiny little 2 up there, I'm going to assume that you think that's an exponent and that you are really not sure what's really happening. So please make sure that it looks nice. Okay, take your time on these. This number should be the same size as the log. This number should be a fraction. It should be with the log. Okay, this number should be a little tiny subscript. All of that stuff is important because it determines what's what when you're talking about those logarithms. So they are very important. So make sure you take your time and write them properly. Okay, so here's another one. Take that x, drop it to the front, so you get x log base b of 2. Okay, x times the log base b of 2. So that was just the answer there, nothing else I can do. Hold on, my screen froze yet again. Okay, now you do have 3 on your own, which I suggest that you stop and try to do before checking your answer with mine. Okay, so you can hit the pause button, see if you can work it out. I would suggest it. Makes this stuff better. It's good practice. Okay, if not, here we go. So log base 5 of 3 plus log base 5 of x plus 2. I am adding 2 logarithms. Okay, when I add 2 logarithms, I multiply their argument. So we get log base 5 of 3 times x plus 2. Okay, when you add logarithms, you can multiply their argument. So 3 times x plus 2, you just distribute log base 5 of 3x plus 6. Okay, you have to have those parentheses or it's incorrect. And that should be your answer. Okay, so the second one, I've got a minus sign. Minus sign means quotient property. Okay, so that means when I'm subtracting logarithms, I'm going to divide argument. So log base 2 of 14/7. Okay, well 14 divided by 7 is just 2, so you get log base 2 of 2. Very last one here. Okay, log base 3 of 5 raised to the x power. It's already written as a single log. All we want is to see it simplified so that exponent by power property can drop in front. So x log base 3 of 5. Okay, so that would be the 3 answers for the on your own. Hopefully you got those right. If not, you can go back through and kind of watch this again and see where you went wrong. Okay, so that's those 3 properties. Now we have to be able to do all of these properties mixed together. Okay, so for instance, if I have something like this. Okay, when I see that plus, then I should immediately think product property. Okay, I'm going to be multiplying arguments, but it didn't say what to do with the number out front. And that's because we don't deal with the number out front. Instead, we use the power property first. Okay, the power property says I can take an exponent and drop it in front. It also says I can take that exponent or that number in front and rewrite it as an exponent, which is what I'm going to do here because I'm trying to simplify this thing. I want to write this thing as a single logarithm. So I'm going to make this thing easier on myself by first moving it up. So you would get log base 5 of 3 squared plus the log base 5 of 2 cubed. Okay, now if I do work these exponents, I would get 3 squared is 9. So log base 5 of 9 plus the log base 5 of 2 cubed is 8. 2 times 2 times 2 is 8. Okay, well now this is nice and easy. So now I'm doing plus, I'm adding 2 logarithms, so that's going to be the product property, which means that I will multiply arguments. These are the arguments. So log base 5 of 9 times 8, which gives me a log base 5 of 72. Okay, so that would be your final answer, single logarithm. I wrote this as a single logarithm, and everything is simplified. I can't multiply or divide or do anything else to that. Log base 5 of 72. So same thing here. Okay, I'm going to start by, anytime I'm trying to write it as a single logarithm, I will start with moving the number up. That's super important. Otherwise, your life is going to get a lot more complicated than it needs to be. Okay, start by moving that number up. Okay, move it back to the exponent spot. So, log base 9 of x cubed minus log base 9 of x plus 1. Okay, now subtraction. Subtraction should immediately say quotient property. So when I'm subtracting two logarithms, I divide my argument. So log base 9, x cubed goes on top because it's first, x plus 1 goes second because it's on the bottom, or it's second. I use my parentheses, and that would be my answer. Nothing here is going to reduce. Again, I've got that plus 1, so those two things are bound. So I can only reduce this with another x plus 1, which I don't have. So that is my answer. Now, when these ones, when they're a little bit longer, it's still no problem. You still just move left to right and use your properties. So going left to right, so log base 4 of 25 plus log base 4 of 3. Okay, plus means product property. So when I'm adding two logarithms, I multiply arguments. So log base 4 of 25 times 3. Okay, and I haven't done anything with the minus log base 4 of 5, so I'm going to leave that there. So we've got log base 4 of 75 minus log base 4 of 5. Now subtraction means quotient property, so now we're going to divide. Log base 4 of 75 over 5, which does reduce. Notice that I don't write log twice. I'm trying to get to a single log. I only write it once, and the minus sign becomes division with just the argument. So 75 divided by 5 is 15. So log base 4 of 15 is my answer. Okay, they also want us to be able to go the other direction. Sometimes it's helpful to be able to expand these things. So when it says, and I want you to look at these directions because these tend to confuse people and they end up leaving the spot blank on the test just because the directions confuse them. Write each expression as sums or differences of multiples of logarithms. That is an extremely fancy way of saying, okay, expand this thing. Expand it out so that you have adding, subtracting in it, okay? That's what we're looking for. So here, I have multiplication and division within my argument. Okay, that's super important. It's all within the argument. This is all part of the log. So, if I want to take division, well, I do the opposite. Quotient rule, okay, so I'm still using the quotient property. We're just going backwards. So, instead of changing the argument to division, we're going to take the divided argument and change it to subtraction. So, log base 3, the 5 times 7 is still here, minus log base 3 of 4. Okay, when we're doing these, we're going exactly backwards from the method that we did before. So before we did the exponents, the number out front. Sorry, let me show you. Okay, the number out front has to move to the exponent spot. That was the very first thing that happens when you're simplifying. Okay, when we expand them, that's the last thing that's going to happen. So first we're going to move the division, and then this is, I can't leave this. Okay, we want to expand these things as much as possible. So if I still have multiplication, division, or exponents, I'm not done. Okay, so here I still have 5 times 7, so that needs to split. Okay, multiplication within an argument can be split as addition of two logarithms. So log base 3 of 5 plus log base 3 of 7 minus log base 3 of 4. And when you look at it, you should be able to go backwards, back down. So when I put those together, plus would become 5 times 7, which is what we had, and then minus would become divided by 4, which is what we had. So that's super important. I should be able to go back down. And once I no longer have multiplication, division, or exponents, I am done. Okay, so looking at the second one, log base 2 of x to the 5th over y squared. Okay, so we're going to try to write this out. Again, we're going opposite order, so the exponents will be the last thing I do. I want to start with division. So log base 2 of x to the 5th minus log base 2 of y squared. Okay, now that I have no more multiplication or division, now I can take my exponents and drop them to the front. And they have to be, this has to be done. You can't skip this step or it will be incorrect. Okay, so minus 2. Notice that this 2 only drops in front of that particular log. Okay, log base 2 of y. That's why we don't move it first, because if I drop the 5 there, that would be both of them to the 5th power. But they're not. Only the x is to the 5th power, the y is only the 2nd. That's why we split first and then move the exponent out. So 5 log base 2 of x minus 2 log base 2 of y is my final answer. No more multiplication, division, or exponents. Now, I say that, and technically this does say 5 times the log base 2 of x. But when I say no more multiplication, I mean within the argument spot. Okay, so in this spot right here, is there any multiplication is what I'm looking for. So C, same exact idea. Okay, start with the division. So I've got log of x plus 3, which I'm going to use parentheses, and I must, minus log of 2. Okay, now this one doesn't have a base written, and these are called common logs, which I'm about to talk about in the next lesson. But anytime they don't have a base written, then we always consider it to be 10. Okay, and you just don't write it. They didn't have one written. I don't have one written. Okay, again, I'll get into more detail about what those are. Okay, but if they don't have a base written, neither do you. As long as they both don't have the base written, okay, then you're fine. So, log of x plus 3 minus log of 2. Now, that's the only thing that we can do. A lot of people want to split the x plus 3, but you can't. You can only do stuff with that if it's log of x plus the log of 3. And then I could multiply them if I was trying to put them back together. So that's a little different. So be careful with those. Alright, now there's 2 on your own. So hit pause, give them a shot, come back, check your answer. I'm going to keep on going because, well, you can just pause me. So, log base 3 times log base 3 of 4 minus 4 times log base 3 of 2. Okay, I want to write it as a single log. It's important to know what I'm trying to do. So that means I'm trying to push this stuff together. That means before I can do that, I can't do division yet because I got these numbers out front. So I've got to move them back up first. So I get log base 3 of 4 cubed minus log base 3 of 2 to the 4th. Okay, so 4 cubed, log base 3, 4 times 4, 16 times 4, 64, minus log base 3 of 2 times 2 is 4 times 2 is 8 times 2 is 16. Okay, that's not supposed to be that big, I just got out of control. So log base 3 of 64 minus log base 3 of 16. Minus means quotient rule, so we're going to divide the arguments. So 64 divided by 16, and you get log base 3 of 4. Okay, so log base 3 of 4 is the first one. Now the second one, they want us to go the other way. Write this as sums or differences of logarithms, which just means expand. Okay, so I'm going to start with the division. So I'm going to go log base 7 of this whole thing, x cubed y, minus log base 7 of 2. Okay, so we got the 2 out of there. Now I can't stop there. This means x cubed times y. That's what x cubed y means. If it was xy, that means x times y. Okay, this is multiplication. I can't leave multiplication. I also have an exponent, but I can't move that yet, because if I move it right now, then that would mean that if I moved it back, I would get xy cubed, but the y is not cubed. So I can't move that yet. I've got to split the multiplication first. So we're going to go log base 7 of x cubed plus, because multiplication becomes addition when I expand, log base 7 of y. I still have my minus 2, log base 7 of 2. Okay, and then final step here, I can't leave that exponent, so I have to take the exponent, and now I can drop it to the front. So 3 log base 7 of x plus the log base 7 of y minus the log base 7 of 2. And that would be my final answer there, log base 7 of 2. Okay, and that right there is the very end, I believe. Let me double check. Yes, that's the end of the properties of logarithms. Okay, 3 properties. You have to be able to use them. You have to be able to use them in more complex problems such as these, where you're using more than one property within the same problem. So make sure you know those 3 properties. It is super essential. Okay, you need to know the quotient, the product, and the power property. You also need to know the special properties from day 1. Okay, I can't stress that enough. There's 3 properties from day 1, okay, that you need to memorize. When my bases match, it's equal to the exponent. When my bases match here in the exponential form, it's equal to the argument in the exponent. And if my argument is 1, it's always equal to 0. Those 3 things need to be memorized, as well as the 3 new properties that we just discussed: product, quotient, and power properties. Okay? Good luck.